Good afternoon, all of you. Myself, Professor N.V. Hadpe from S&D College of Engineering and Research Center, Yoga. So now today we will discuss about the classification of resistance and its measurement by using various techniques. This topic will be available in the course of electrical measurement and instrumentation. Then the overview of that subject is electrical measurement. Means what is the measurement of the electrical quantity? The measurement of a given quantity is the act or result of a quantitative comparison between an unknown quantity and a predefined standard quantity. The measuring process is a process in which a parameter of an object or system is compared with a standard object or system for that particular parameter. For example, for measuring weight of a quantity, the standard taken is 1 kilogram. This is a classification of resistance, that is low level resistance, medium level resistance and high level resistance. The value of resistance which is less than 1 ohm resistance, that is low resistance. In between 1 ohm to 100 kilo ohm, this is your medium resistance, and above 100 kilo ohm, it is high. It is considered as a high resistance. This is the classification of resistance. The method which is used to measure the low resistance, measurement of low resistance. The major problem in measurement of low resistance is the value is contact resistance or lead resistance of the measuring instrument. So being small in value is comparable to resistance being measured and hence causes error. Means suppose contact resistance, means suppose one small resistance which will be measured, that is 1 ohm or 1 milliohm, then the resistance which is the wire which is used to measure this resistance should be also included in that measurement. Thus, to eliminate these issues, small value resistors are constructed with 4 terminals. 2 terminals are current terminals and other 2 are potential terminals. That is the method which is used, the Kelvin double bridge method, potentiometer method and Doctor ohm meter method. The measurement of medium resistance is the method which is used to measurement of medium resistance, that is 1 ohm to 100 kilo ohm. The ammeter voltmeter method means the ammeter, by using ammeter and by voltmeter, the 2 meters will be used for measurement of resistance. Wheatstone bridge method, in that the bridge method will be used. Substitution method, Carey-Foster bridge method, ohm meter method. The method which is used for the measurement of high resistance, that is loss of charge method, Megger method, mega ohm bridge method, direct deflection method, or tester method. The first method which is used for measurement of resistance, that is Wheatstone bridge method. This is the simplest and most basic circuit which is used in a measurement study. It mainly consists of 4 arms of resistances P, Q, R and S. R is the unknown resistance. R is the unknown resistance under this experiment, while S is the standard resistance. P and Q are known as the ratio R. The value of that P and Q are also known. And EMF is source, the one DC source which will be connected between the points A and B, while a galvanometer is connected between points C and D. In that, we will check the bridge balance condition by using that galvanometer. Means when the supply is given to that bridge and At that time, suppose the current will be flowing to the galvanometer, means the galvanometer shows the deflection. That means the bridge will not be balanced. Bridge will not be balanced. In that condition, we will change the value of yes resistance. Change the value of yes. Then this will be used for making the bridge balance. For making the bridge balance, change the value of yes. Up to that, the current flowing to the galvanometer shows the zero deflection. The galvanometer shows the zero deflection. A bridge circuit always works on the principle of null deflection. That is null detection. That is, we vary a parameter until the detector shows zero, and then use a mathematical relation to determine unknown resistance in terms of known resistances. Here also the standard resistance S is varied in order to obtain null deflection in the galvanometer. This null deflection means there is a no current will be flowing from point C to D, which implies that potential of points C and D is same. The potential at point C, Vc is equal to Vd. The potential at point C is equal to potential of point D. Means suppose the potential, both the potential are same, then the current flow into that link should be zero. Means according to that bridge balance condition, the point at D and point at C, the voltage at point D and voltage at point C are equal. Means the current, the voltage drop I1 into P is equal to I2 into R. I1 into P is equal to I2 into R. And also I1 is equal to I3. I1 is equal to I3 because there is no current flowing to that galvanometer. Means the current, that is I, is always flow to the D, and I2 is equal to I4. The current will be same current will be flowed to the towards the point B. Means the current I is nothing but the potential difference across point A and B, that is E upon P plus Q. P plus Q, that is total resistance. And the I2 is equal to I4 is equal to potential difference across point A and B is, that is E upon R plus S. E upon R plus S. This is equation 4 and this is equation 5. Then by solving this equation, means put the value of I1 and I2 in that equation, then I1P means E upon P plus Q is equal to E upon R plus S into R. Then cross multiply, E will be cancelled, cross multiply, R P into R plus S is equal to R into P plus Q. Then PR plus PS is equal to PR plus PQ. PR get cancelled. Then PS is equal to QR. PS is equal to QR. Therefore, R is equal to PS upon Q. PS upon Q. This is the final formula for finding the value of R by using Wheatstone-Bridge method. The value of R is unknown value. P upon Q is a ratio resistance. Means the P upon Q is given as a ratio. Suppose P/Q is equal to 1:2, or P is equal to 10 and Q is equal to 2 times of P. This is your ratio resistance. This method is widely used for measurement of electrical resistance. When the variable resistor is adjusted, then the current in the galvanometer becomes zero. The ratio of two unknown resistance is equal to the ratio of value of unknown resistance and adjusted value of variable resistance. This is the your piston bridge method. The second method, that is ammeter voltmeter method. We know that the ammeter, which is used for the measurement of the true value of the current flowing to the any resistor or the any conductor, but the voltmeter does not measure the true value of voltage across the resistance. Here, voltmeter indicates the sum of the voltage across resistance and ammeter. Let voltmeter, the voltage of voltmeter be V. Then, from that, suppose this is a ammeter voltmeter method. There are two way of a connection of ammeter and voltmeter method. Suppose voltage is connected before the ammeter and ammeter is connected after the voltmeter. This is the first method. And second, in that second connection, ammeter is first before connected to the voltmeter and voltmeter is connected after ammeter. Then to measure the resistance of a medium value of resistance, both the connections will be connected. Then the value of resistance is equal to voltmeter reading. Voltmeter, the reading shown by the voltmeter to the current or the reading shown by the ammeter. That is V upon I. It is your resistance. When the internal resistance of ammeter is zero, when the internal resistance of ammeter is zero, and the internal resistance of voltmeter is infinity, the internal resistance of voltmeter is infinity, then the measured value of resistance is true value. It is true value. But suppose the ammeter, the internal resistance of ammeter having some value, some small value, suppose 1 ohm, 2 ohm, then this will be produce an error. This will be produce an error. In that case, suppose in some cases Ra is the resistance, internal resistance of ammeter is not equal to 0, then it will be causes an error. It will be causes an error. That is, the voltmeter shows the voltage across resistance as well as the voltage drop across ammeter, because this voltage drop will be occurred due to the resistance of ammeter. Resistance of ammeter means, suppose in any circuit there is a one resistance, there is any one resistance, then there is some voltage drop. There is some voltage drop is available. Then by using that Rm, the measured value of resistance is equal to V upon R. That is VR plus VA upon I is equal to IR plus I into RA. RA means the resistance of ammeter upon I. I get cancelled, means Rm is equal to R plus RA. Means the measured value of resistance which is greater than the actual value, which is greater than the actual value of resistance. Due to this, due to what? Because of the internal resistance of ammeter. This second, that is error. Error is nothing but Ra upon R. Means, suppose Ra is less, means the ammeter resistance is less, then the error should be less. In the second method, suppose the voltmeter measures the true value of voltage across resistance, but the ammeter measures the sum of current through voltmeter and R. Due to what? Because the value of the internal resistance, the value of internal resistance of voltmeter is very high, but it is less than infinity. But it is less than infinity. Due to this, the sum current Due to this, some small current will be flowing to that voltmeter. Due to that, the ammeter shows the reading IV plus IR according to KCL. Then V upon R is equal to V upon IV plus IR. IV must means V upon RV plus V upon R. V common, then 1 upon 1 upon RV plus 1 upon R is equal to 1 upon cross multiplication R plus RV upon RV into R, that is RV into R upon R plus RV. That is the measured value of resistance. This is RV into R upon R plus RV. Means it will be producing some error. Some error. This is your ammeter voltmeter method. Means in that lecture we will we already discussed the two methods, that is Wheatstone bridge method and ammeter voltmeter method for the measurement of resistance. Okay, so stop here. Thank you very much.